A longtime champion of sustainability, Northeastern University recently partnered with Grundfos to help reduce energy use on campus. The project involved replacing 350-plus conventional pumps with smart pumps that use up to 80% less energy. There are approximately 500 pumps in the 75 or so buildings on Northeastern's campus. The amount of water moving through the buildings is tremendous, and so is the amount of energy used to move it.
Northeastern University is a well-recognized leader when it comes to adopting energy-efficient technologies, and they work very closely with their utility, Eversource, who's also a leader at influencing the adoption of energy-saving technologies. So when those two heard about Grundfos energy-saving pumps, it coalesced into a partnership pretty quickly.
Smart pumps were still a new technology, so Eversource suggested the school start with a pilot program. Northeastern jumped at the chance to prove the potential energy savings to both itself and the utility.
So we had two goals. First, to verify the energy savings, and second, to show that the pumps worked, so that the school had confidence that they could adopt the technology. So we focused on three main pump applications: heating pumps, domestic hot water recirculation pumps, and pressure boosting pumps.
Before the project, many of the pumps on campus were just on or off. There were no controls, no advanced logic. The new Grundfos pumps operate on demand, delivering only as much water as needed and using 80% less power than the pumps they replaced.
One of the reasons we have the ability to have these great savings is a functionality called AutoAdapt. And what AutoAdapt is a self-optimizing control logic where the installer or the operator doesn't have to put in any parameters. And what the pump does is it learns the characteristics of the system over time and adjusts accordingly.
Installation and maintenance are simple too. The domestic hot water pumps snap right into place, and the larger pumps are skid-mounted for easy servicing and added reliability. If a pump were to fail, one of the other pumps on the skid would kick on automatically to prevent disruption and eliminate the need for manual switchover.
So far, the project's going great. We've seen over 1 million kilowatt hours of savings, and we're not even halfway done.
The opportunity for dollar savings is in excess of $300,000 a year.
Even though the project's total impact won't be apparent until the end of Phase 3, the university has already seen significant capital improvements and energy savings, both of which are expected to grow by the time the project is complete.
The biggest success to come out of this project is we're able to prove that there's a huge opportunity for energy savings with smart pumps.